Hello everybody. Today we're going to talk about combining like terms. So before we actually get into combining like terms, I want to review the definition of a term. So a term is a number, a variable, or the product of one or more variables. So again, it's a number, any number, a variable, any variable you could think of, or the product of one or more variables. So for example, something like negative 4x squared y to the sixth would be the product of one or more variables because it's negative 4 times x times y times y times y times y times y times y. Okay? So, and the negative 4 is what's called a coefficient. So again, that term in purple would be the product of one or more variables. So down below I have an algebraic expression, okay? And there's three terms in that expression. Terms are separated by plus or minus signs. And the sign for any term is found to the left of it or in front of it. So for example, if I look at the 9, that's a positive 9 because there's a plus sign to the left of it. If I look at the 5y, it's actually a negative 5y because there's a minus sign in front of the 5. And the 3x is also negative. Okay? So the sign for any term is always found to the left. Very important. Now let's talk about like terms. So in order to combine like terms, we can only combine like terms. So like terms are constants. Now constants, you might not have heard that term before. I'm using different the actual English term before. But constants are just numbers. So any two numbers, if they're just regular numbers without variables, and it could be integers, fractions, decimals, whatever it may be, if they're just numbers, those are constants. So like terms are constants, or terms with variables that have exactly the same variables and exactly the same exponent or exponents. Now that S in parentheses, that means it could be singular or plural. So again, like terms have exactly the same variable or variables in them and exactly the same exponent or exponents in them. Okay, that's what makes terms like. The coefficient in a term does not matter. And let's talk about the parts of a term briefly. So here we have a term, and most of us know what the 2 is called. That's called an exponent, right? Exponents are written high and to the right of something. Now, if you don't see an exponent for something, if there's no visible exponent, the exponent is actually 1. Okay, just keep that in mind. So again, I'll say that one more time. If you don't see an exponent for a variable or a constant, its exponent is 1. Okay, then we have the x. Now, we know that's a variable, but the name we're looking for here is something that has an exponent, and that's called a base, like in baseball. Okay, and then finally, the negative 3. That's a number multiplied to a variable expression in a term. That's called the coefficient. Okay, so the number that's multiplied to a variable in a term has a fancy name. It's called the coefficient. Okay? So there's your parts of a term. Okay, you have, and every term could actually have these, even though you might not see them. So for example, if I just write an x to the 4th, well, believe it or not, that has a coefficient of 1. So if you don't see a coefficient, it's 1. Okay? If you don't see an exponent, it's also 1. All right? So like terms, remember, have the same variables and the same exponents. The coefficients can be different, though. So if we look at two different terms. So I have negative 4x and 8y. Those are not like terms because they have different variables. Okay? Now if I have, let's say, negative 6x to the 4th and negative 6x squared. And actually, let me change the coefficient, even though the coefficient would still not change, what I'm trying to do here. So if I have these two terms right here, these are also not like, okay? And the reason they're not like is because of the exponents. They have the same variable, but the exponents for those variables also have to be exactly the same, okay? So these are also not like terms. So what are like terms then? Well, a set of like terms would be something like negative 4y to the fifth and negative 10y to the fifth. Those are like terms. The coefficients can be different, but notice they have the same variable or variables, so they both have y, and those variables have exactly the same exponent. So these, in fact, are like terms. And we'll talk more about adding them right now, but just in case you're wondering, if we combine these two like terms together, the answer would be negative 14y to the fifth. Okay? So we talked about the parts already. And when you're combining like terms, guys, you're always adding. So we just did distributive property, right? Distributing is multiplying, where combining like terms is adding or addition. So keep that in mind as well. So one more thing before we start. When you combine like terms, you keep the variable and exponent the same. That's something very, very important to write down. And I'll say that one more time because it's so important. When you combine like terms, you keep the variable and the exponent the same. Okay? All right. So if you see the wording simplify, that either means to distribute or to combine like terms or both. But since we have no parentheses, it means to combine like terms. So if we look, I like to use shapes for our like terms, and I like to include the sign with that. So we have a negative 3x, and I see another x over here, negative 11x. So those two are alike. Now I love putting the coefficient in those because now we add these together. So a negative plus a negative stays negative, negative 14x. It is not, and I hate to put bad ideas in your head, but it is not negative 14x squared. When you combine like terms or add them together, you keep the variable and the exponent the same. Okay? So now we also have another set of like terms, 9y and negative 31y. We add those together. Since we're adding a positive and a negative, we're actually going to subtract. So we're going to subtract 31 minus 9, which is 22, and keep the sign of the larger number, which is 31, so we keep that negative, right? So negative 22y. And that's our final answer. Okay, so we simplified this expression by combining like terms. So let's look at another one. We have negative 6 minus 7x plus 11x minus 2z minus 4.3. If any time I'm going too fast, just stop the video. All right? So we look to identify our like terms since there's no parentheses. So first we'll start with the numbers. We have a negative 6, and do we have any other constants? Well, we do. Negative 4.3. It doesn't matter if that's a decimal and that's an integer. We could always make that a decimal, right? Negative 6.0. But these are constants, or just plain numbers. So we can add those together. Negative 6 plus negative 4.3 is negative 10.3. If you need to, you can set that up vertically, but it's a pretty easy one for most people. Do we have any other like terms? Well, we have these two with the x. Negative 7x and positive 11x. When we add them together, adding a positive and a negative, we subtract, keep the sign of the bigger number, positive 4x. Okay? And this negative 2z, there's no other z's in the problem, so we actually just bring this down. So that's our final answer. Okay? Simplified all the way. I'm going to make that decimal point, a little bit larger so you can see it better. So 4x minus 2z minus 10.3 would be your final answer. You don't have to express it exactly in this form. This is what's called standard form. Standard form for a algebraic expression or a polynomial expression is with your terms with the exponents from highest to lowest. If there's no high exponents, typically you do the variables in alphabetical order. Although I'm not too picky on that. I'm more concerned that you're able to get the correct answer. But if you want to get really technical, we could also write this answer as negative 2z plus 4x minus 10.3. These both are mathematically correct or the same. Here's why. As long as the signs to the left are the same, your answer is correct. Okay? So again, the specific order isn't that important unless they really want to know what's called standard form. It's just important that you get the sign for each term correct. That needs to be 100% correct. Okay? Let's look at another example. So here we have negative 8x squared minus 10x minus x squared plus 3x. So since there's no parentheses and we're simplifying, that means we're combining like terms. So we're looking for the same variable and exactly the same exponent. Well, these two have the same variable and the same exponent. Now you might ask, what's the coefficient for this negative x squared? Remember, if you don't see a coefficient, it's 1. So it's usually very helpful for people to write that 1 there, and now it's actually a negative 1, right? So now it becomes very easy. Add these two up, negative 9x squared. Remember, when you're combining like terms, keep the variable and exponent the same. And that's only for combining like terms or adding, okay? Keep the variable and exponent the same. Something really, really important to write down probably. And now we have negative 10x and positive 3x. When we add those together, we get negative 7x because we subtract, keep the sign of the bigger number, which is negative 10. All right? Okay, to finish it off, I'm going to give you 2 problems. Try these on your own and see how you do. Okay, so here's your 3 problems. So I want you to simplify these completely. So go ahead, try these on your own. So at this point, the next 30 seconds are going to be blank. So pause the video, do these in your notebook, and then check to see how you did afterwards. This is such an important step. Don't skip this step, guys. Do the problems on your own for sure to make sure you're understanding the content. Okay, so let's go over these. So the first one is actually distributing, right? So we distribute the negative 10 to both these terms. That's a review of the previous lesson. We get positive 40x, and a negative 10 times positive 7 is negative 70. And now we actually look to combine like terms, but since these aren't like, that's the final answer for number 1, 40x minus 70. Number 2, what like terms do we have? Well, we have a 4y and a negative 11y. And then we have a negative 16x and a 1/2 x. Whoa, fractions. Well, this is why we spend so much time working with fractions, okay, and reviewing our basic operations. So we are adding these two together. So off to the side, I'll do negative 16 over 1, right? That number's over 1, plus 1/2. We got to get common denominators. So our common denominator would be 2. So I actually make this then a negative 32 over 2, right? And now we could add the numerators and get negative 31 over 2, okay? If you wrote negative 15.5, that would also be correct. So negative 31 over 2x, and then combine the y's together, we get negative 7y. That's your final answer for number 2. And then finally, number 3, got a little tough to see the exponent there with my final answer there. So we have negative 16x squared plus 20x squared y plus xy. Well, although it looks like they're all like terms, they're actually not. This middle term here is not like with the other ones. Because remember, like terms have to have exactly the same variables and exactly the same exponents. So only these 2 terms have exactly the same variables and exactly the same exponents. And remember, the exponents for the x and y in both these terms is actually 1. So there's a 1 there and a 1 there. You just don't see them. But you can combine these 2 like terms, where 1 is the coefficient, negative 15xy. And since this term right here is not like with anything, just bring it down. And if we're talking about standard form, we'd probably put that positive 20xy in front, but that's not that important. I just want you to make sure you get the final answer and combine your like terms correctly. So thank you very much for your attention. Hopefully you found this video lesson helpful. Again, if you have any trouble, don't be afraid to research this online. There's plenty of resources out there on the credible math websites on combining like terms with algebraic expressions. All right, so again, thank you very much. We got to finish with a picture, right? So there you go. We do our best to make math fun, even though we're learning virtually right now. And I want to make sure we institute maybe some Kahoots and different things like that throughout the year, especially help you review for tests and quizzes. So there's a cool picture. Make math fun. All right. Maybe I'll color his hair yellow. How cool is that, right? Awesome. All right. Well, thank you very much for your attention. Just having a little fun at the end here. Have a fantastic day, everybody. If you have any questions, please let me know. Thank you.